Picture the moments right before a critical operation. A highly skilled professional is preparing to do their job with absolute precision. Now step out of the hospital and into the hangar. Opening up a LightSport Rotax engine requires that exact same methodical mindset. Every step is a calculated move designed to keep the aircraft safe and the pilot in the air. Because lives depend on this machinery functioning perfectly, our maintenance process is built on a foundation of absolute discipline and strict written procedures. Before a surgeon makes the first incision, the patient receives anesthesia. Before we touch an engine, we have to put it into a deep, safe sleep. In an airplane, an engine is considered hot, meaning it's ready to fire up at any second. To keep it quiet, we ensure the grounding cable is connected. This wire acts like a safety drain for electricity, pulling energy away from the engine's ignition system and into the metal frame so it can't create an accidental spark. Looking at this diagram, we see the engine is directly connected to the propeller. If that electrical safety drain isn't working, simply turning that propeller by hand can send a spark through the system and accidentally start the engine. To safely tame the engine, we disconnect the battery, confirm the ground is secure, and establish a safety zone. We also wait for the engine to cool down entirely to the outside air temperature to prevent severe burns. If you're enjoying learning the ropes of aviation maintenance, take a second to like this video and subscribe to kick off your aviation journey with us. When you follow these steps, you realize the most dangerous moments of aircraft maintenance happen before a single wrench is ever lifted. So why are aviation mechanics so incredibly obsessive about keeping their workspaces surgically clean? In a hospital, dirt brings infection. In an engine, dirt and tiny metal chips cause contamination that ruins moving parts. This cross-section of a fluid line shows what happens when foreign material gets inside. A jagged metal chip can wedge itself directly into a narrow valve, completely blocking the flow of cooling or lubricating fluids and causing internal pressure to spike. Because of this risk, mechanics must use only the specific cleaning agents and solvents listed in their maintenance instructions before they can reuse any disassembled parts. Maintaining a sterile workspace is the only way to ensure the engine's internal systems remain clear and functional. That brings up another common question. When we take the engine apart, can we just reuse all the nuts, bolts, and seals we removed? Think about how a doctor handles medical supplies. They would never reuse a sterile bandage on a new patient. Likewise, a mechanic never reuses certain safety items on an aircraft. Once they are loosened, specific mechanical parts, like safety wire and self-securing locking nuts, go straight into the trash. This technical illustration shows the specific sealing components that also require brand new replacements. Every time we disassemble the engine, the O-rings, gaskets, oil seals, and sealing rings must be swapped out for fresh ones to ensure a perfect seal. Replacing these inexpensive, single-use parts is the ultimate insurance policy to protect a highly complex and expensive engine. If you watch a mechanic work, you might wonder why they draw little markings all over the internal components as they take an engine apart. Think about your favorite pair of everyday shoes. Over time, the insoles compress and shift to mold perfectly to the unique shape of your feet. Metal engine components do the exact same thing. In this microscopic view, we can see two metal surfaces rubbing against each other during flight. Over time, they develop microscopic wear patterns, smoothing out to interlock perfectly. When disassembling the engine, mechanics carefully mark these pieces. This ensures that when the engine is put back together, those parts return to their exact original positions, preserving that specific fit. If you mix up these parts, those matched surfaces will begin to fight each other, causing the metal to grate and grind down until the engine fails. Every procedure we've talked about relies on one ultimate authority. Just as surgeons follow strict medical protocols, aviation mechanics are bound entirely by the manufacturer's manual. This is especially true when it comes to tightening every bolt. Mechanics don't guess how much muscle to use. They follow torque values, which are specific measurements of twisting force that ensure a bolt is exactly as tight as the manufacturer designed it to be. This graphic demonstrates the dual dangers of ignoring those twisting force measurements. On the left, a connection that is too loose will quickly vibrate apart. On the right, tightening a bolt too much stresses the metal until it stretches and snaps in half. The mandate for every technician is clear. You must obtain, read, and thoroughly understand the specific instructions for your LightSport engine. following them word for word. Aircraft maintenance is not a matter of brute force. Keeping an aircraft airworthy requires a careful, clean, and highly structured approach. Aviation runs on precision, safety, and a commitment to continuous learning. Thank you for visiting the hangar today, and we'll see you on the next flight.